All right, hi everyone. Raise your hand if you're a nerd. Yes, good. All right, you don't have to keep it up for the full 10 minutes. All right, I was a nerd. Oh wait, hold on. Wait. Why is the video not playing? Hold up. All right, there we go. All right. So I've been a really big toy nerd all my life. That's me back when I was like, I think it's like 9 or 10 years old. I found a bucket of Kinects, and I was in love with things that moved. And as I grew, I became more of an airplane nerd. So you can see me over here flying one of my wings, the awkward teenage stage where I was doing Olympiad and flying these rubber-powered airplanes around. And then I eventually graduated to like making big things and doing competitions. That big red airplane is about 6 or 7 feet across for a sense of scale. So I did all these RC airplanes, and I decided that's what I wanted to do in undergrad and came to MIT for grad school, where I led the development of the Locust Micro UAV. This is a small airplane. It's about the size of a dollar bill. Some of you guys may have seen me demo it yesterday out in the tent. And the idea was, okay, there's a lot of missions where it may be really useful to be able to have a lot of little airplanes fly around. If any of you have seen the movie Twister, you remember Dorothy, where you launch a number of probes to go measure the things inside a tornado. You can also do the same thing inside hurricanes. You can use this for communications. You can use this for ISR, for military missions. And it's because a big airplane can hold a lot of these. You can fire out like 100 at a time and just have them fly around and do their mission. And so here is the team I led with some of our professors. And over here, this plot shows you the weight of aircraft that are available, and over here is the altitude. So we are all the way up there. So this is kind of a brave new world. We're really, really tiny, but we're really, really high up. And the size of the dot represents the endurance time of these aircraft. And we actually fly pretty long for something that small. The vehicle we decided should come along with a case. This is the protective case, and this really enables the mission to happen. Think outside the box a little bit. Tack on extra parts. And the way it works is that there's a release mechanism here and spring-loaded hinges, and this opens up like a clamshell. And the airplane itself is made of a big low-drag Kevlar fuselage. The wings here are spring-loaded, and it's got a pusher propeller. So during deployment, this doesn't need any servos or motors or solenoids or whatever to deploy. Everything's spring-loaded. The moment that release mechanism triggers, you just pop open and you start flying. The reason why this makes sense is because the whole system is designed around that deployment system, the one I showed you with the flares launching from the big transport aircraft. The airplane folds up this way, and the case here directs the ejection force around the aircraft, so the aircraft itself can stay light and stay efficient. And here's a video of the wings deploying. And the way this is designed is that it comes out, and then during deployment, the case will open like that. It generates a lot of drag. The airplane itself, which is a lot less draggy, will continue to fall. All right, so this also generates kind of a problem. You have this airplane that now pops out. How do you control it? The way we decided to do that was to have a series of servos and wipers which automatically engage the control surfaces at the back of the wings here, like that. So that as you deploy, your wings automatically come into contact with these control surfaces, and and by pushing down on them, because they're spring-loaded up, that allows you to control the airplane. There's a lot of fancy micro-aerodynamics. I won't get into them for this talk. But designing these wings and designing this control mechanism was one of the big challenges of the project. So this is another thing that I'll owe to my years of flying RC airplanes, is that I was a test pilot for these little airplanes. And so here we have a video of us flying them around. Really pain in the butt to fly, by the way, because they're really tiny and hard to see. But explore your passions. You don't know when they're going to come into use. And in this case, my years of just playing around with remote control toys was really helpful in the development of our vehicle. And there you go. And so at MIT, the team that I led, we developed the airframe, which is and also the propulsion system. So this is designing the wings, the fuselage, how all that fits together, how it deploys. And to conclude our efforts on campus, what we decided to do was, okay, we want to demonstrate this entire system as it drops. So here's a composite shot of a test we did with a balloon platform. And over here on this side, you can see the deployment case as it falls away from the vehicle. And the vehicle here is traced out in the orange light, the orange line. And you can see how it, as it deploys, it falls away and it launches into its own flight. All right. So look us into Perdix. Perdix, you may have heard, is the production version of this vehicle, and it's developed at by our good friends at MIT Lincoln Laboratory, which also helped to fund the project. And it was actually featured on 60 Minutes a couple of months ago, where they actually built 100 of these little airplanes and launched them out of F-18s over the China Lake testing range in California. And so remember, like, you're building these little toys, but they have real impact. And this is now kind of like a big deal and a real thing that will be spooling up soon. And I wouldn't be surprised if in a couple of years you'll get multi-point telemetry information about hurricanes or storms, or you'll see these on the news and they'll be chasing bad guys around the desert. But you see a lot of them flying around. And by the way that these work is that they have onboard autopilots each, and they generate a mesh network. So all you have to do is to tell one of them, like, go explore this area. They'll tell their friends, and they'll all fly over there, and they'll perform their mission to be able to fly around. So you're commanding not an airplane individually, but the whole swarm. And that's also a new paradigm that happens. All right. So my personal tips for you guys as budding inventors: buy broken stuff and fix it. That up there is my motorcycle, or actually this is my old motorcycle. And you can see two things wrong with it. First of all, there's a big puddle of oil on the ground where there shouldn't be any. And second of all, there's a laptop hooked up to it because the computer on board didn't work. So you buy it, you don't even know if it's going to work. Just do it. I mean, it's find stuff that's cheap on Craigslist and just play around with it. You learn an amazing amount by looking at what's broken, how it broke, and how other people have proposed fixes in the past. This is my car door. When the speakers blew out, you actually discovered that, oh, hey, the reason why it blew out is because there was rust. Why is there rust? Because there's water. Why is there water? Because the window seal up there failed. So if you were to design a car, you probably want to look out for that. All right. Notice the little details in life. I mean, I don't miss the big picture, but you pay attention to the small scale too. A really innocuous daily thing. So these little bread tags, right? If you fold them, they turn white. Why? Well, it's because there are both amorphous and crystalline structures inside that plastic, and that is actually because your strain energy put into it causes the polymers to crystallize. Little other things. This is my favorite tidbit about commercial airplanes, by the way. Anytime you get into an airplane, look above the door. All right? There's always this line. Okay? It's not there for strength, because every single door has it, and it causes extra drag. So you would put it inside if you knew it had to be there. The reason why it's there is it is a rain gutter. Okay, this is a small, clever device that keeps people dry as they board on the airplanes. It's pretty cute. And lastly, find a passionate community. Here's a picture of my friend's truck. We were going up flying on top of the mountain. Here's a bunch of airplanes, and here's a bunch of us flying. But don't believe everything they say. Don't be afraid to be a rebel. Learn from your colleagues, but play, keep polite heart, and you'll do great. All right, thank you.
All right, thanks, Tony.